We have motors and compressors that turn on with electrical. They have electric current that turns them on. They carry the voltage through to turn on the motors and compressors. There's different types of contactors. You have to be careful what you have and what the purpose of it is if you ever have to get one to change it. Contactors work with higher amp draw than relays. Amp draw is the amount of power that it's going to do, that much work to do. It's pulling more amps, is doing more power. When motors start, they start at lock rotor. So you have a shaft sitting dead still. Even in a compressor is an electric motor. You have to turn that shaft. That's lock rotor. It takes a bunch of power to kick it. If you read the tag on a motor, FLA is between 2.8 and 2 amps, depending upon the load on that motor.
Yeah, it doesn't
So
say.
lock rotor amps is probably around 10 to 12.
Yeah, 12,
Yeah.
4 times that, right?
So the cap will be 7.5. Is that what the cap will be?
No, the
No.
cap is what helps the motor start. The lock rotor is what it pulls for a couple of seconds before it turns. That's what burns motors up. So there's devices to start it. But I'll get into that after the fact. So you've got contactors that turn on compressors and motors. I'm trying to go by the paperwork. Contactors come in multiple poles. Single pole, 1.5 they claim, 2, 3, 4, sometimes 5 and 6, depending upon the purpose. It'll tell you what the rating of it is and what it should pull. There's inductive and resistant. Here is a 40 amp 3-pole contactor.
Okay.
Somewhere on here should be another number higher, higher than 40. Sorry?
The RES.
Yeah, 50 resistant.
Yeah.
Lock rotor
Mm-hmm.
is the resistant. So when that motor starts, if it's a bigger motor, and it's starting at 60 amps lock rotor, it's gonna toast that contactor real fast.
Yeah, it's gonna burn.
Even though running, it may only run at 20 amps.
Yeah. But this is
But
start.
the initial start,
It's gonna
because
kick it
when
out.
those contacts pull in, it's an arc between the jumper bar and your wires coming in. So you have to be careful what part you get to do the job. And on top of that, the coil that is energized, power goes to the sides normally, sometimes it's tucked in on the bottom. There's a coil of copper underneath it that becomes an electromagnet when power is put to it, and it pulls the contacts in. The coil itself gets rated for voltage. There's 24 volts, there's 120 volts, and there's 240 volts. But you have to be careful of the voltage to the coil and what it's going to do and what it's going to pull for the load you're putting on it.
You gotta match it for whatever you're using.
Yes.
Correct.
And there are cases where oversize the contact.
Mm.
It,
Can't take them nowhere.
low voltage will burn up the motors.
What?
So
Resistance
what
40,
they
40,
do
40.
is,
Okay, the resistance.
you have a transformer that runs a low
Starting
voltage from
30.
240 down to 24. Everything gets exaggerated as you
Yeah.
use a transformer to step it down.
Yes.
You can't do over 40.
So when you
No.
have a low voltage condition, instead of 208 coming in, you hit 200. Your 24 volt now drops down to 18. The coil of the contactor pulls a set amount of power. Now you have low voltage going to that coil. That board says we have low voltage, we have high amp draw off the coil. We must have a problem, and shuts the machine down. So if you take out a 60 amp contact and put in a 75 amp contactor, the next size up, you're gonna keep locking out because it thinks there's a problem and there's not. So you have to watch what parts you put in and replace for the parts you took out. They've gotta be close to a match, or at least know what you're doing with it. You wanna try to get your resistance as close to a lock rotor as possible so you don't burn it
Right.
up. And if it's a one shot and you turn it on and it runs forever, not a problem. You got past that initial start to kick it to go.
So as long as you can get past that.
As long as it's on, it's good.
You're
Transformers step down power,
Okay.
and that's what runs our control circuits.
Alright.
There are multi-tap transformers and different VA, which is volt times amps, for the power that it's going to use. Be careful you put the right one in. You can step it up to a higher VA transformer, just refuse it. Because 40 VA takes a 3.5 amp fuse. Or you're and you can see the smoke rolling out as it melts. No joke. You have, if your machine came with a 40, that's what ultimately you want to put back. There's 40, there's 50, there's 75. But 40s are what's typical in a residential or light commercial.
We've dealt with a lot.
These are 3.5. So you have a whole system that's designed to be protected by a 3.5 amp fuse, or the smoke at 4. So you put in a 75 VA that has a 5 amp fuse. Are you gonna melt the thermostat off the wall? Are you gonna melt wires together when something goes bad? 75s come with a little mini breaker on them. That's okay, it's a 5 amp breaker. You can still put a 3.5 amp fuse in the circuit to protect it,
Sure.
to save the rest of your stuff, to save the PC boards. Multi-tap means you have different voltages input off the same one. Wired nut off wires separately that don't get used. Don't take all the wires that have extra and put them in one wire nut, because you will hear that sizzle real quick. So that's a 40.
Me and my dad want to.
This is a 75. A lot bigger. There's multi-tap on them
120.
for a very specific reason. When you go up to the machine, I don't think there's 110 on there, but you could have a 110 volt circuit inbound. You could have a 208 voltage circuit inbound. You could have a 230
Who's
volt
passing the same one around?
Oh, wow,
It's
these are mostly
system
the same,
inbound.
huh?
You could have a 460 volt inbound. And you have to get down to 24.
Okay.
You have to have the right one.
To the light.
Always check. Typically, residential is 240 volts.
Yeah.
Commercial, any 2 wires is 208, not 240. So if you don't have it wired right, you will screw with your output voltage because it's multiplying. So if you need 24 volts and you have a commercial application and you have 208 volts and you wire 230, you're not going to have 24 volts out.
No.
You're gonna start beating up on all the rest of your machine, your components. On your paperwork, basically, that's a transformer.
I knew.
There are multiple different kinds of motors. There are many different sizes, many different horsepowers, and different ways to control them. Typical residential and light commercial uses 3 kinds of motors. PSC motor, which is permanent split capacitor, has to have a capacitor to run. The X13 motor is not from outer space, but that's where it belongs. And the one on the right is an ECM motor. Yeah, we have really weird names in this business. ECM, electronic commutation motor. They do different things. That one lasts, those don't. They don't because of installers. Those motors fail because of the electronics. Because installers didn't learn how to do their job.
Ah.
You cannot.
What's the static pressure for supply duct? Residential, typical light commercial supply. What's your supply static pressure?
I honestly don't know the answer to that.
What's a manometer? Typical supply static pressure is 0.1
Okay.
inch of static pressure in your water column in the supply duct. That's what the unit's designed for. Sorry guys, we live in Florida. How cheap can we make this crap?
What is that?
Supply status.
Flex duct everywhere.
Mhm.
Flex duct, even in the building code, does not exceed 6 feet. It's not an air distribution system. It's a connective duct.
Yes,
Right.
static is 1.
I'm sorry, return is 0.05. 1.5 times return to the supply.
Return is what?
Return is 0.05. So when you have the air going across the motors now are after the coil. So you have air going across that coil that cannot move the correct volume of air that the manufacturer designed. So the motors get colder than they're supposed to. When the machine turns off, they condensate, and you get moisture, and it scrambles the programs. It scrambles the components that keep the program memory. And you can walk up on a machine, remember, this is a service class, not install.
Yeah.
ECM motors, you'll have an intermittent problem that you may never catch until the motor finally dies. You can sit there and turn the machine on, and those motors will sit there and just rock back and forth and not spin. But what happens if it doesn't hit full RPM? It runs 3/4 of the RPM required. You're not gonna see that, but you're gonna create more problems. Your refrigerant charge isn't gonna be correct. You're gonna have machines freezing up. Why? Well, put the gauges on it. It's overcharged. Suction line's coming back too cold. No, the motor's not turning fast enough because it wasn't installed correctly.
Right.
Where is the blower on the train? Plastic.
It's on the reverse. It's underneath the
Correct.
coil.
It blows
Yeah,
through the
pushing.
coil.
It's pushing air, not pulling it.
Yeah.
It's not in the cold air path. It's in the return air path, not the supply air path. That's how to get around motors fail.
Ah.
Yeah,
But that is old school. That's the way it used to be.
Right.
You push the air through the coil. You don't try and pull it through the coil.
We got.
But they just need to do with like a metal case though, not a plastic one.
Yeah.
Yeah, so you can seal it up. So you're not blowing air out everywhere.
Yeah, because we were working with one of those, and I walked by it, just waved my hand over it, and you could feel air just purging out of the damn thing.
Tape it shut.
Yeah.
You know what causes that?
X13 motors are going by the wayside. That was the first improvement. And that all goes back to the feds. We have to have a seasonal energy efficiency rating of this. Guys, it doesn't work through the whole country. We live in different environments.
Mhm.
This
Yeah.
isn't the same as Arizona. This isn't the same as Wisconsin. Different applications have different problems.
Swamp.
We have issues with motors that we have to deal with because of it, and because of, believe, our power company. And it's not just here,
Duke.
Duke. So we're building houses and apartments everywhere you look.
Your electrical goes up
All they
less
want is
than
money. What's
10%.
it do for 'em?
No,
Yeah,
but we still have an infrastructure that can't handle the power that we need.
Past couple of years.
That's why they're trying to go to the ECM motors
Mm.
that do some reduced power. There's another way to reduce power consumption, and that's with a different kind of air conditioner. Depending upon the manufacturer, VFD or VFR. Glorified mini splits. Because they operate differently. They don't have lock, rotor, drawer. You get into the big commercial equipment, we'll have 30 horsepower motors. You can't flip a switch and expect that motor to take off on a contactor.
No.
It doesn't work that way, trust me.
Yeah.
You still have to start that stuff.
Yeah.
So the compressors start with Y windings, and then contactors drop in another set, pull in, and they change the configuration and they go to delta. Because Y windings start with a lower amp draw than delta does, but delta winds up higher, will spin a motor faster than Y windings. So when they start, especially the older ones, any seasoned technician at the 10-second mark, the hair on the back of your neck stands up. Because you're waiting for everything to drop in and out. Because if it doesn't, the panel explodes.
That's funny.
All right, so imagine working on a 1,000-ton chiller, and you have to service the contactor, and you open the panel, and guys, it stood this tall, it's on wheels. You grabbed it and you rolled it across the floor. And you service it, and you slam it back into the pegs to hold it in place. Can't keep doing it with all the machines, we don't have a power grid for it.
No.
So That's the compressors. The motors start by changing. We have voltage and we have frequency. Electric frequency in the United States is 60 cycles.
Mm-hmm.
Well, what if you change the cycles to a motor? You can get that motor to start rolling slowly with no lock rotor amps. Very little amps to get it to start rolling slowly. That's how we drive great big motors. They're bringing that down into the regular, smaller market. You asked what that was. 4 in 7 months. Mother Nature took them out. Power switches. Somebody got a knife?
Yeah.
Take the cover.
It's not the old one.
Scroll top. It's fully programmable. You program it to your voltage, you program it to the amp draw, doing some calculations off the motors between the amp draw that the motor's rated for, the inbound voltage. That's why I started. You need to understand basic math skills. How fast you want the motor to wind up to the RPM that
Like
you
what base?
want, and you have to program it to what you need it to do. Programming one of them anywhere from 10 minutes to 2 hours, depending upon what you have to do with it. But that'll start a motor without lock rotor amps, there are no contactors needed for those.
So what that does, just starts it up slow until it gets it to the
Here,
speed
start that.
Yeah.
and then-
Yeah.
And we program how fast we want that motor to wind up.
to wind up at.
You can have static pressure sensors that if you start closing dampers off, it'll start slowing the motor down so you don't overpressurize the system, blow the blower apart, blow the ductwork apart, depending upon how big it is and what you want it to do. There's multiple ways to turn motors on and off. And then the VFD, VFR, variable refrigerant flow, and
VRV.
VRV, variable refrigerant volume. So we can adapt a compressor speed to what we have for capacity. We don't have to run a compressor to 100%. If we have systems, we have rooms dropping off because they're satisfied. The other tool, believe it or not, that we have to use in this service business, guys, laptops and thumb drives. There are phase monitors that you program. If the voltage spikes up, drops down, phase is reverse. One phase drops out, it turns everything off, it kills the power. Turn off whatever you want to control with it. There are surge protectors,
That's,
mini splits, whether it's done per room or on the commercial end, is what is going to be more commonplace. And the more commonplace it becomes, the more you're going to have to become computer literate. It goes in that direction, the more issues that creep up. I changed out a condenser on a dual head mini split last night because lightning hit in the backyard and took out a board in the condenser. Their policy, Daikin's policy, you cannot buy it without a surge protector. If it fails, when it comes back,
being a surge
if that surge protector's not with it, you're eating it.
it.
Generation coming up, yeah, of mini splits. So you've got a condenser, the refrigerants go up to the head, and you vary the refrigerant volume. We have PC boards in the heads, we have PC boards outside. We have disconnects that you have to have within 6 feet of the condenser outside. By law, by code, you have to be able to turn it off within 6 feet of a condenser. Air handlers, if it's in a garage and there's an electrical panel, if it's line of sight with no obstruction, that's acceptable. On the mini splits, you have to have a switch at the inside unit. And it has to be a 3-pole switch. The switch has 3 independent legs, like the contactor. Breaks all 3 legs at the same time. That's building code, that's facility.
Right.
You cannot break two wires, you have to break all 3 wires. Because depending from manufacturer to manufacturer, which of those 3 wires are hot? are 208. Mitsubishi 1 and 2.
What?
Daikin 1 and 3 volts.
Oh.
There's 3 wires and a ground. Out of those 3 wires, 1 is hot. Mitsubishi 2 is hot. 3 is communication. Daikin agree 1 and 2. 1 is hot. 3 is hot. 2 is communication. Now, when I said about being computer literate in PC boards, what do you do when you go to a machine that is running, but you're throwing a code for lack of communication on one head, but only when the third one's connected? Let's say, hypothetically,
All the way down.
you're installing a 3-head system by the book, literally by the book.
Mm.
You don't have to start all 3 heads at the same time. So you bring up 1 and 2, and you start calling the structure off while you're doing 3. In this case, it's A, B, and C.
Mm.
So you connect up C, and it boots A offline for communication failure. You disconnect C, A comes back to life. Take all the readings, everything shows good, like it's supposed to. Connect up C, it boots A offline. Which PC board's bad? Shouldn't be any.
Right.
No.
You can't necessarily just swap the wiring because the refrigerant lines going to that head work with the wiring. C runs constant, no problem, but it boots A offline. Because I call this one into tech support, this one another problem child.
Okay.
And they're kind of like, you're kidding, right? No. This case is give you all brand new equipment. So I don't want brand new equipment.
Mm.
I want the board. There's so many people out there that don't want to take the time to learn like you guys are doing now.
Mm.
Read manuals. Today's technology, you can get manuals offline. Read the manuals before you install it.
Oh, yeah.
And not only read the installation manual, read the IOM manual, installation operation manual. And always be nice to tech support. Always be nice to counter. Have everything that you can ready for them. Pressures, voltages, amp draws, everything. And befriend them for whatever brand you're using most of all.
Mm-hmm.
And it turned out to be 1 resistor and 1 PC board that was creating the problem.
The way that the system is wired up, it doesn't use a thermostat, it used a proprietary controller. The thermostat cable actually had to be grounded to the evaporator. Whatever was going on with the resistor, it was interrupting the frequency that the wire was supposed to be sending back and forth from the controller to communicate, to tell it to turn stuff on and off right. So I just fashioned a RF meter out of some headphones that I didn't like. Found the radio wave, isolated the resistor and said, well, here's your problem, it's this one. It was like a 9-cent fix.
What do you do when you put a Goodman in and you're under the length of the line set where you don't have to add new refrigerant? You open the valves and you start it up, right?
Yeah.
Nothing works right.
Right.
Nothing.
No.
What's the problem? It's a brand new machine. Wound up pulling the whole charge. Evacuating it, change the dryers, re-evacuate it. A brand new charge. It worked fine. The industry has changed. We're going to high tech.
Right.
But unfortunately, we're going to high tech, being made by idiots. We're hiring. Businesses hire and try to get the cheapest labor they can get.
Yeah.
So be very careful what parts you use. Check your parts before you put them in. When you buy a motor, before you leave the parts counter and put it on your truck, open it up, spin the shaft. Put it on your truck. Before you install it, take it out, spin the shaft. But when you get into the motor, the capacitors start motors. There's start caps and there's run caps. An old man told me the easiest way to tell the difference. A run cap is metal. A start cap is Bakelite, black plastic. always will be. Different sizes, depending upon the motor or the compressor, motor in the compressor. It tells you what you have to put in. You can't deviate. That's what you have to install. Otherwise it doesn't work, it burns the motor up. And then you have these lovely Turbo 200 and the Turbo 200 XL, where you build the cap you need. There's numbers all around the side.
It's like a customizable capacitor.
Exactly.
So all metal are run and all Bakelite are start, correct?
I think they
You can
changed
have
the
a
whole
plastic
end of
run
that.
cap. if you
Oh,
really
that's
want
right.
to,
No, yeah.
But
I
they've
remember
done away with those.
Drew and I-
You check the capacitor, even if it's brand new. They're rated in microfarads and voltages.
Okay.
Typical run cap, excuse me, typical start cap, only comes to 2 voltages, 370 and 440.
370, what is that?
370 volts and 440 volts.
440. So that's the start
If
one,
you
right?
don't have a 370 volt capacitor, you could put in a 440. I don't stock 370s, because you can always put a 440 in place of a 370, but you can't put a 370 in place of a 440.
Right.
The typical way to check the capacitor, they come rated in what's called microfarads, is with a cap checker. And today they actually build them into the meters. The old way of just putting ohm meter on it and reversing it just tells you you can switch power. There are single caps and there are dual caps. A dual cap are 2 capacitors built into one. That's all. Unless you have that beast that has multiple. So on a dual cap, you always have one common lead. And then you have the other ones, commons in the middle.
Okay.
The difference in the motors, if you buy a motor, you need to know the frame, you need to know the horsepower,
Yeah.
and the RPM. On their tag, it'll say FR, 48.
And this is correct, right?
Yeah.
The FR48 frame is a 48 frame. On the catalogs, you can look them up. A 48 frame gives you the diameter of the motor and the size of the shaft. A 58, which they're out there,
And you just make what you
has a 5/8 of shaft. It will mess you up when you get a half-inch fan blade up and it doesn't
I
fit.
like this one better.
A thermostat is nothing but a bunch of switches set into one. It will power fans. It'll power reversing valves. It'll power fans. It'll power auxiliary switches, depending upon what you program it to do, if it's programmable, what it's designed to do. Heat pumps have a 4-way valve, a 3-way valve, a reversing valve, depending upon who you talk to. But a heat pump basically is an air conditioner put in backwards. But since you can't physically change the pieces, we change the piping to the coils. And that's done with the reversing valve. That has a coil on it, a magnetic field that causes a pin to slide inside, and it uses the refrigerant to push the valve one side or the other. That's powered by the thermostat or by the PC board, because we have to deal with PC boards too. It's cold outside, 40 degrees, it's raining, which is the worst time for a heat pump to run. 35 to 40 winds raining, not 2 degrees. That window, the outside unit freezes up fastest. And you have to clear the ice off the coil, because when the outside coil builds up with ice, you do not have the capability of removing the heat from outside and bringing it inside. So the PC board has sensors on the coil, and it says, guys, we need to go back to an air conditioner. Heat the coil up to clear the ice and dry the coil. So you have this great big whoosh, and the little old lady homeowner calls the fire department because her air conditioner's on fire, because the smoke's coming out of the top. It's just steam. But you heard this great big noise when the valve snapped. PC board said, time to go, caused it to happen. That PC board with all its switches to do that Also has a switch in it to turn the heater on, the heat strips in the air handler to temper the air. So it's all electrical. Make sure the motors are good. You could ohm out a motor with an ohm meter and tell you if it's what you have, but you really don't know if it's good unless it's grounded. So you have continuity from the wire to the housing. Which, believe it or not, you could still have it and the motor's still good, depending upon where it stops inside. Pay attention to what's there. You have catalogs. Dig in that catalog. There's a lot of information in there, not just for air conditioning parts. Do you know how to size a freezer? It's in the book. Little mini ductulator settings, typical, are in the catalog. Charging charts are in the catalog. If you have to extend out the refrigerant lines past normal, you have to change the size of the refrigerant lines. It's in there. And I said, this is a service class, not an install class. You have a bad compressor. You change it out. 30 days later, you lose another one. Why? Do you have a kink in the line? Are the lines the right size?
Yep.
The easy way to battle around that is, okay, you're going to take out copper that's twice as thick of a wall as the one you're putting in. And the copper you're taking out is round. The copper you're putting in is oval. But it's supposed to be round. If it's not round, you're not moving the volume of refrigerant.
Right.
You're not bringing the oil back to the compressor. And you're going to smoke the compressor for lack of oil. You can take the fan blade off and you can change the fan blade and put it on the new motor. If that blade's out of balance, it's going to eat up the bearings on the new motor. If you bend that blade, taking it off inadvertently, it's going to cause a wobble. What do you do when you keep going back to a machine that eats up motors?
Change the blade.
Yep.
Okay? What do you do if you change the blades and it still keeps eating up motors? You're the service tech. You gotta step back and look at stuff. What's the 3 kinds of basic motors?
ICM and the E14 thing.
And a PC, wasn't the other one PC something?
Yeah, PC computer.
PSC,
Okay.
Yeah,
X13,
X13.
and an ECM
Which is electronic, that's what I'm saying, electronic.
motors for multiple horsepowers. That's why that PSC motor has an amp rating. That's not just one, it goes in a range. Because of the load that gets put on it. You can't arbitrarily go change the motor and increase the horsepower. Doesn't work that way. Because the higher the horsepower, the thicker the motor, the taller the motor. Which means you may not get your fan blade where you need it to be. Fan blades are critical when they go into the cowling. They have to be set in a certain spot, or you don't move the airflow. Blower wheels, you have to have that squirrel cage in the right spot, centered in the blower housing, or it doesn't move the airflow. So when you arbitrarily take out a motor, take out a 1/4 horse, and put in a 1/2 horse, and if you can get that blade in there where it needs to be, it's all good, but you might not. You cannot switch speeds. You cannot take the new motors, a lot of the new motors are 850 RPM. The base motor is 1725, which means that shaft turns at 850 revolutions per minute or 1,075 revolutions per minute. If you take out an 850 RPM motor and you put it in 1075, you will have to triple the horsepower
Make it.
because of the weight, the pressure put on the blade. That's going to transfer to the motor. Horsepower is a work, it's going, when you change out a motor, there's stuff called never sees. It's worse than mastic. Coat the shaft with never sees. Coat it with grease. Lock the set screws down tight. Because if you ever have to change it again, you don't have to fight that hard to get it out. The very top of that shaft.
That's the weakest point, if it's spinning like that.
Right, it puts more pressure on the bearings.
Exactly.
Put it as low as you can.
DMR.
This shit, when you put a motor in and you replace the motor, be very careful whether you need a rain guard or the plugs that are in the motor. Make sure they're in the right direction if they have to be rotated, and make sure they're in the right end. There's little black plugs in the top of that motor. If the motor is shaft up, they better be there. And the plugs off the bottom of the motor have to be out. They're weep holes. They have to let the condensation out. You're going to toast the motor. Trane has a habit of not putting plugs in their motors. You have to buy a rain guard that goes on the motor before the fan blade does, and it covers the top of the motor to protect the water from going into the motor.
Yeah, it's showing.
The motor, the PSC motor, is a condenser fan motor. The other two motors are evaporator motors because they're multi-speed. You can change the speeds on those motors. And the quickest way to tell is the holes that are inside of those motors cannot be in a condenser fan motor because it'll fill full of water. Condenser fan motors have to be protected from the rain.
Yes, so.
And there are reversible motors. If you change out an ECM motor, they have directions with them. The first thing you have to do is power it up and just let it sit, because that motor will spin in both directions until it finds the direction that it needs to go in. It will tell itself by the pressure, and it will continue to run that way. It doesn't do it every time, just the initial startup. When they go bad, it will slow down, and they will sit there and rock back and forth. You could spin them and get them to go, but it's going to fail again. When you change out parts on the X motor, you can buy different components. It comes in 2 pieces. The manufacturer recommends you change both pieces because it will fail in 30 days. That's their average run. That goes into what do you do, how many times you're going to put a torch on the system. Flare dryers, when you can. Even the Zoom Lock, if there's enough refrigerant, if there's enough copper, they have dryers at Zoom Lock fitting school. So you cut the copper off and you just snug it up a little bit more, put another Zoom Lock on. No torch, you're in and gone. There's different ways to do it. When we talked about the mini splits, when you have multiple heads on one condenser, the manufacturer doesn't tell you until you get deep into the literature that every head is supposed to have a set of valves at the head as well as at the condenser, so you can change them out.
I feel
Wow.
like we do that anyway.
I know.
Now, when you talked about changing dryers out so much, it used to be standard practice that when you put in the dryers, you put in T's and valves. So you can isolate your dryer from the rest of the system. And the rest of the system could actually run while you're working because you had a valve at each side and you had a valve in the bypass. Open up the valve in the bypass, valve off your dryer. Change your dryer. And the rest of the system, you haven't touched.
You don't have to pump it
You
down or
haven't
anything.
introduced anything into the rest of the system.
Right.
Just that spot. When you open up machines on the ground, or 7 stories up, contactors work by an electromagnet. You're putting power to a coil to make an electromagnet to pull in the contactors. Ants are attracted to magnetic fields. They do go rooftop, and they will full a contactor full of dead bodies and take a machine offline.
Scrapey with the file.
Yup.
No, take your phone out and take a picture of it before you touch it.
Yeah, this thing is riddled with corpses.
Yes, and
Because when you go to a bank, and you tell them the ants got up on the roof and took out the 100-amp contact. So you can always take that contactor down and drop it on their desk on the book, and when the
Right.
body's falling, go, okay, what do you want me to tell you?
Yeah.
You're-
But we're
Please don't
dealing-
tell me you think I killed all these ants and individually
Well, I
put
don't
them in there.
Yeah, we're dealing with stuff that
That's why I know, that's
homeowners,
why I know.
think they know.
know.
because they check with mechanic Google, and they have no idea what really goes on, for the most part.
He said coupon.
So
That's what he said.
protect yourself.
Mhm.
Phones are great. If you have to change a thermostat, or change the contactor inside of a commercial unit, take a picture of the way the wiring is.
Oh, I do that.
Carrier makes some equipment that's really hard to work to change out a contactor. It's wedged up in the top, and you have about 40 wires going past. It's very, very tight to work in that space.
Mm.
Even trying to take a picture of it becomes a problem.
Yep.
Carry a sharp. Little lines, 1 hash mark, 2 hash marks, 3 hash marks.
Right.
If you can take the part out, unscrew it from the base, change wire for wire. Take one wire off the terminal, put it on the other.
Mm.
Take another wire off and put it on the other. So you don't make a mistake when you put it back in. Because moving one simple wire can be a
A lot
catastrophic
of stuff.
event.
Yep.
A compressor has 3 wires going to it. You have the common, the start, and the run. If you inadvertently cross the run and the start windings, you have about 15 seconds. And then you don't have a compressor anymore.
Nope, it's dead, it broke. No.
You will short the winding down. For motors, there are 3-phase motors. That is meant for 3-phase motors. Motors generally are reversible, sometimes they're directional. And you have to pay attention to the direction the fan blade is going. If you change the fan blade and there's a cover on top, be very specific for the blade you get, because if you're going against the grain of the louvers on top, it's not going to work. But on a 3-phase motor, it has no rotation. If it goes the wrong way, switch any 2 wires, and it'll reverse its rotation. Because you have 3 legs of power, and it will spin, there are no capacitors needed. And if you have somebody not paying attention at the parts counter, tell them you need a start cap for the 3-phase motor.